Assalamu alaikum. In this video we will learn about aromatic hydrocarbons. So what are aromatic hydrocarbons we will discuss in this video. And aromatic means the benzene ring, and it was discovered by the Michael Faraday and isolated by Hofmann. We will discuss some properties of aromatic compounds. So basically aromatic compounds contain benzene rings. If whether it is one ring, two and three and so further on so on. And benzene has total 6 carbon atoms and 6 hydrogen atoms. So the carbon atom contain a double bond at the adjacent position, and each carbon attached with a sigma bond with hydrogen atom. So two possible ring structures are these are the hybrid resonance hybrid of each other. So this is the structure of benzene. And these purple balls are indicate the carbon atom, and these blue balls indicate the hydrogen atoms, and these are the double bonds at the corresponding carbon. And this is the structure of benzene ring. So next is what are arenes? A compound containing one or more benzene rings are known as arenes. And this one is the benzene ring, and the other that contains two benzene ring is known as naphthalene. Naphthalene is the common name of two benzene rings that are attached to each other. And the aromatic compounds have we name as when benzene as the parent chain. Um we will name benzene ring as a parent name, and the other rule is name of substituent comes in front of the benzene ring. So we will see what is the group that is attached directly to the benzene ring. In this compound, this is methyl group, and we will name it as methyl, then benzene. Okay. The other compound is um, carb hydrocarb sorry halogens, and this is the benzene ring, and we will name it as chlorobenzene. Next is the group attached to the benzene ring is ethyl group, and this ring is known as benzene, so we will name it as ethyl benzene. Next is naming of aromatic compounds. So when we use the common names for these compounds, that is if the group that is methyl group attached to the benzene ring, the common name is toluene. When the hydroxyl group attached to the benzene ring, we will name it as a phenol, and the other is named as anisole. And when the ammonia group attached to the benzene ring, it will name as aniline. The other is aldehyde group that is attached to the benzene ring, it will known as benz aldehyde. And if the carboxylic group is attached to the benzene ring, it will name it as benzoic acid. The next is uh, naming of aromatic compounds when two groups attach to the benzene ring. So we will name the ring. Before naming the ring, we will write the numbers, and ring the we will write the numbers, that is we consider it as we will number the compound with the least number, as we will see the first compound. So we will prefer the group that we will name it as parent name, that is benzoic acid. And if we count from here to there, then it will not be considered as the least number. We should give the least number to the other group. So if we consider the numbering from here to there, then it will be the fifth position bromo. And if we count from here to there, it will be number as second or 2. So we will prefer the least number, so we will name it as 2 bromo, and the parent name is benzoic acid. The other is the first rule is the special name start numbering from the special name. So the special name is benzoic acid, this group. And if we do not have um, the special name, number them to give the get the smallest set of numbers. So in this second example, we will see two groups, same groups attached to the benzene ring, and how we will number it, as we will not do or number it from this side, and we will prefer this side numbering because it will give the least number to the other group. So this is the name. As if we there are two names, if we consider the number one as a parent name, so we will name it as toluene. Okay, it will be named as special name is toluene, and the third position has methyl group, so 3 methyl toluene. The other name is 1 3 dimethyl benzene. And the other example is that contains two groups on 1 and 4th position. And uh, we will see the special name that is uh, special. It has no a special name, and we will name it as alphabetically. Chloro C will comes before E in the alphabetic order. So we will consider the one chloro and two 4 ethyl benzene. Next is if we have three or more substituent attached to the benzene ring. So rules are same. If we have a special name, we will consider it, and if we do not have a special name, then number them to get the smallest set of numbers, and we have to give them the least numbers and list them by alphabetic order. So in the first example, we see three groups attached to the benzene ring, and one will consider as a special name. So in this compound, we give toluene the special name, and the other is nitro group, and other is chloro group. So we will number them and write them by alphabetic order. So chloro means C will comes before the N. Nitro group, and we will write it as the number 4 chloro, 2 nitro, and the parent name toluene. Okay, next example is that contains four substituent. The one is we will take it as parent name, that is phenol, and the other groups that attached are same halogens and bromo. So we will name it as 2 4 6, the numbering 2 4 6 and 3, because there are three and same groups, so we will write as tri bromo phenol. The other is we will consider this as a parent name nitrobenzene, and we will write it as after numbering uh, 2 bromo, because B comes before ethyl group. So 2 bromo, 1 ethyl, and 4 nitrobenzene. So The next is the physical properties of aromatic hydrocarbons. So, firstly, in the absence of polar substituents, arenes are typical of hydrocarbons. So, in this rule, in this property, these properties are because if the benzene ring does not contain a polar substituent, then these are the properties of aromatic hydrocarbons, that they have low melting and boiling points, and their solubility in is low in polar solvents such as water. The other is the chemical properties of benzene. So they can resonate their pi bonds, okay, and their resonance structures are stable, and they can uh, does not give the addition reaction, and because they are unreactive in the addition reactions, and they cannot they give they does not give the final product, and because they are unreactive in the addition reaction, but they give products in the substitution reactions such as halogenation, nitration, and sulfonation. So this is the end of the topic. Thank you so much. Allah Hafiz.